I'm Chet Haase. I work on the framework team on the Android team at Google. I work on animations and all kinds of graphics stuff. What excites me about the platform is basically all the same stuff. Doing graphics for mobile devices, very cool stuff. How to improve the user experience and make these devices and the applications better and more exciting.
My name is Romain. I work at Google on the Android UI Toolkit team. It's also the framework team. I've been working on the UI Toolkit, some SDK tools, animations in the past. I've been doing graphics, the launcher, live wallpapers, a lot of stuff. I've been on Android for 4 years now. And I love it because it's challenging. We have those tiny devices and we have to make really cool stuff working all the time in your pocket. So extremely cool.
All right, so we're going to talk about tips and tricks and techniques. This is a discussion about some internal stuff that we encountered working on the framework that you might want to be aware of in your Android app development. It's also a discussion of tools, techniques that you can use to tune your application or see what problems are occurring and what you can do about it.
And actually, he's pretty serious when he says that it's stuff that we've encountered, because I think the past 4 or 5 weeks of our life, we've spent them doing exactly what you're going to see in this talk. So it's all like real techniques with real tools that we use every day to make Android happen.
Given by real engineers. So this is my first foray into mobile device development. I spent the last several years working on other platforms, but always desktop. And there are a lot of things about using desktops and virtually unlimited memory and CPU that you don't really worry about anymore. Things like garbage collectors automatically taking care of things, and so might as well litter the universe with garbage because that gives them something to do. Then the garbage collector doesn't get bored. It turns out that actually matters on mobile devices more than I thought it would. They're pretty hefty CPUs, and you have a fair amount of memory down there, but in particular for the kinds of things that I've been working on for animations, if you have an animation and it's just running really quickly, like 200 milliseconds, 1/5 of a second, and it gets in the middle and there's a little GC pause in the middle, that sucks. It's really bad, right? So it doesn't pause for that long. It's not like when Java 1.0 first came out and you'd have this 1 second pause in the middle of something that everyone groaned about. It's nowhere near that bad, but it is a noticeable hiccup. And so that was important for the work that I'm doing because it's basically the inner loop of the animation. What can I do to make those things more efficient so that your application don't experience these kinds of delays? But it's also stuff that you might want to think about for the inner loops of your applications. So I basically spent a few weeks while one of the big parts of any platform development is crafting the right API. It's not just about the implementation, it's about putting in the right classes and methods the first time, because you're going to have to live with that platform forever, right? It's not like we can say, gee, the class name color matrix color filter really sucks, I'm going to change it. Well, your applications depend on it, right? As soon as we put it out there in the public API, it stays. For the most part, unless nobody's using it and it's deprecated and there's some weird situation. But for the most part, stuff stays around, so you better get it right the first time. So I think about APIs a lot, and I had a particular thing that I was trying to do with some of the APIs where I realized, okay, well, it might be better if I use generics. So let's push generics into the API, and that will make it easier to declare this and that for the reasons that I had at that time. And then I took a look at what generics did, to the API. They made it really ugly with all kinds of warnings in your code and all kinds of angle brackets all over the place. And B, they started creating garbage all over the place due to some AutoBoxing stuff that I'll talk about. So this is a discussion about some of the stuff that I investigated in basically spending the last couple of weeks ripping generics back out of my APIs and getting rid of them and stomping on them until they were dead. So I had this concept called garbage zero. I had this goal when I saw what generics were doing. I wanted to take a look at canonical animations that I was creating and say, okay, what can I do in the APIs and the functionality of the animation APIs to make sure that no garbage is created, at least due to the side effects of the animations themselves. So you can definitely go over the top here, and I would not recommend that. I don't think it's necessary to really worry about the intricacies of garbage in everything that you do. But if you're talking about the stuff that I was doing or some inner loop, then it's nice to keep some of these elements in mind. So here's a concept, and a lot of these are really simple concepts. It's more like, if you were programming 20 years ago, maybe this would have been really important, but maybe you've forgotten it since then. So it's worth mentioning. So We do this a lot in the framework because a lot of the framework really is in your inner loop. That drawing code, you're going to spend a lot of time in that drawing code. We want to make it as efficient as possible. Well, if we need a point object, if we need some temporary object, what we generally tend to do is to create a static or an instance variable, depending on the situation, and actually use that as a temporary instead. So here in this case, in the first code up here, we say, okay, well, I'm going to create this new point because I need a point structure to call this other API over there. Well, that's all well and good, and it's a cheap object to create, but you're calling a function, and you're sort of wrapping up objects, and you're doing a bunch of stuff every single time you enter that inner loop function that maybe you don't need to do. And more importantly, at least for my case where I was trying not to create any garbage, you are creating garbage. It's a little bit of garbage, but you know what, if you're running 10 simultaneous animations and you're running that over a second period, that may create enough garbage to actually trigger a garbage collection. So maybe instead you want to create a static variable or an instance variable and say, you know what, create this object once and simply reuse it when I need the temporary. And also, I mean, it goes without saying, you should be careful with this stuff, right? If you have a multi-thread safe application, you know, you want to make sure not to do this in places where you're just going to make your code buggy instead of garbagey. But it can work. AutoBoxing, so this is fun. So all the new stuff that they did in JDK5 for the Java language was really cool. It made it a lot easier to write the code that you ended up writing all the time anyway, you know, casting between big float and little int and big integer, and the for loops that you would have. It made it a lot easier to write the code and to read the code. It was really nice syntax, and it creates a lot of little tiny bits of garbage along the way. So for instance, in this code up here, we have x, which is a little float, a primitive type, set to 5, and then we set big float, the object version of float, equal to the value of x. Well, that's just like saying, okay, I want a new float object, and here's the primitive type float to create it with, right? So there's a little bit of garbage. And then I want you to call this method, which takes a big float. Now I'm passing it a primitive float, but it's actually going to cast that into a big float, and for that it's going to create a new big float along the way. Again, a little bit of garbage gets put on the heap and then eventually needs to be collected, right? So maybe it's a little bit better to just use primitive types when you can. You avoid the object creation, and you also avoid the AutoBoxing in and out. There's no conversion, automatic magical conversion that the Java language will do for you, but it's, you know, adding up along the way, right? It looks free in the code, but the stuff going on underneath is basically what you used to do in your manual code before JDK5 to actually create these objects and derive primitive types from them. Also the iterase, the fact that I no longer have to use iterators is awesome. You can instead use this for loop, which is like really streamlined, right? It's very little code to actually iterate through this collection, which is really cool, but it's doing the same damn thing underneath that it used to do. You don't have to write it anymore, but that doesn't mean it's not being done. Right, so when it's walking through this list of nodes, it's basically creating an iterator and then walking through, right? Which in a lot of situations is totally fine and totally appropriate. But what if you came in here and in most cases in your inner loop, actually node list was empty. The object exists because, you know, it always is going to serve the function of having nodes if it needs them, but in most cases maybe it's actually going to be empty. Well, it's going to create an iterator first, and then it's going to walk through this empty list. Wouldn't it be nice if you simply checked the size first before you went ahead and just arbitrarily created the object by calling the for loop syntax? Recycling bitmaps. Romain talked about this before. It's really important because these are very limited resources and very large objects that you're taking up. So if you've got a 256 by 256 bitmap, if you've got a bunch of those created and you're creating them temporarily, let's say you have some scrolling list of bitmaps or thumbnails that you're using, and you have tons of these things, but they're not all on the screen at the same time. Well, you want to make sure to aggressively collect those things because otherwise you may just run out of memory. So you would think in the modern days of garbage collecting VMs that this would be enough. You would say, well, I'm done with my bitmap, so set it to null, remove the reference, maybe it was a local scope reference, we're all done with this. Well, this is not a synchronous removal of the native memory, right? This just says, you know what, I have no reference to this thing, anymore, so go ahead and collect it. And the garbage collector, at some time in the future, will collect it. But depending on the rate at which you're creating the garbage, the rate at which you are trying to create other bitmaps, you may actually run out of memory when you think that nothing's wrong, right? Like, I may have no reference to any of those 1,000 images that I just created, and now I'd like to create 1,000 more. Well, the references don't exist, but the native bitmaps may still exist. So if you can manage your bitmaps in particular situations where you are in memory-sensitive situations, if you can manage them, then you will not run into the memory situations, the out-of-memory errors that this is going to cause otherwise. So go ahead and recycle them. Okay, so yeah, finalizers. I mean, there's a general tip about finalizers in the Java language and other platforms in general that, you know, they're great for eventually taking care of the native memory or other details you need to clean up, but eventually is the key word. If you need it taken care of now, then manage it yourself. Varargs. So this is the original problem that got me into the generics issue, was trying to get varargs to sort of do the thing I wanted, and I decided generics was the answer, and then I decided I hated generics, and I won't use them again. So again, this is really convenient syntax that came around in JDK 5, where you can take this arbitrary array of objects passed into a method and just sort of conveniently declare it as, you know, well, this is, you know, possibly an infinite array of objects. And then they can pass in as many as they want, which is great, but it means that an array is going to get created along the way. So you need to take that into account. Do you really want there to be a little bit of garbage created every time that method is called? Okay, so here was the essence of my problem with generics. Is that the T doesn't actually stand for primitive type. It stands for object type. So in my case, I wanted to have some simple animations that are generally going to animate ints and floats. And those are primitive types. We pass around primitive types all the time in the framework. The dimensions, the locations of things on the screen, the layout params, these are integers or they're floating point values, right? But if I create a generic class that says, okay, well, I want this animator object to be of type T, and then knowing that it's of type T, this, you know, generic syntax, if anyone's familiar with it, then it's really convenient because then I can make assumptions. I can say, okay, now I'll call the, you know, the T-based method of this other class or whatever. Convenient, but messy in terms of garbage and these object types. So this my class of T becomes, if you pass in a float value, if it's a primitive type float, it'll automatically get AutoBoxed into a float. And you've created garbage just by creating one of these objects, right? So be aware that generics are not free. They're convenient, and they do have really unattractive angle brackets. I want to emphasize that here. They're really ugly, and I hate them in my code. But they also create garbage. Is there something good about them? There is. There's actually really good things about generics, and they're lovely in collections, but not in the animation APIs.
It makes your code look like XML.
Yes, it does make your code look like XML, and we all love XML. Allocation tracking. Okay, so we're going to take a look at some tools in a minute here, but there's some programmatic things that you can track that you can use to track the things going on in your code. If you're getting into an inner loop where you want to create no garbage, but it's a little bit hard to see, maybe, you know, this function calls this other function which does this other thing conditionally, but you want to make sure that in all cases no garbage is created because, you know, you've run into situations similar to what I was facing, then you can actually tell the debug system to set an allocation limit of some number, say 0. And then it'll throw an error if garbage is actually created along the way. So you can basically say, I don't want anything to be created, and it'll say, okay, I can do that for you. And then it'll throw an error if there's a problem in there. And you can also count the amount of stuff being allocated with this other call down here to start allocation counting, and then you can go ahead and request the allocation count that's currently been made. So DDMS is the tool to know about. It's actually sort of the Uber tool that has several tools inside of it. So let's take a look at a demo here. So I wrote this application called Trash Talk. Let me run it on here. And Trash Talk does a few of the things that I talked about so far. So the first part here is way up at the top. Run the test. So when you click on the button, it's going to run this simple test that does a bunch of assignments in here. It's going to say, okay, well, it's going to run the test with a float value with a primitive type, and then it's going to automatically AutoBox that into the object float type. It's going to call some method that takes varargs. We're going to see what happens there. It's going to create a generic class with that float object. So the important thing to note here is we gave it a primitive type, and it's going to do all kinds of nasty things with it instead. So if we run DDMS and we select the process and then do that, this is going to start allocation tracking, and I'm going to click the button a few times and see what happens. Now we'll go in here, we'll click stop, and it's going to pop up another tool called Allocation Tracker. Start tracking. Now go back to my demo, click the button a few times. Get allocations. This is going to give you a list of everything that was created between the time that I clicked Start Allocation and the time that I said, okay, now get me everything that was created. So let's take a look at a few of these. So ArrayList iterator, where was this created? So in run test on line 54, this is kind of hard to organize here. Line 54, we're iterating through in this for loop. Empty list is, I should point out, you can see here it's an empty list. And we're going to run a for loop, which is basically not going to do anything, but along the way it's going to create some garbage. So it's going to create 24 bytes of garbage every time it hits that for loop, even though nothing happened. So we can see a few of those happening for the 10 or 12 times that I hit the button. Here's a float array being created on line 48. Yeah. Oh, yeah. Double click there and it takes you to the line. So when I call the varargs method, which takes an array of floats, or it takes this varargs of floats, it's going to create an array of floats along the way. Okay, so there's a couple of things to note here with all of this sort of tedious walking through the tool thing. One is, I didn't lie on the slides. This actually does create little bits of garbage along the way. The other is, Allocation Tracker is really cool. TraceView is too. But Allocation Tracker is really useful for tracking this stuff, because it's not just, hey, garbage was created, or you see a GC in the logcat. No. It's much more powerful. It tells you exactly what was allocated, where it was allocated. You can go to the line of code and say, oh, I get it. Generics suck. All right. Okay, so there's another part to this, which is, I also wanted to say, okay, well, what if you were trying to track the region that that the user moved their finger in, and so I'm going to create this object along the way and say, so I've got this sort of expanding region as they click down and they drag around. Then that's going to call this other code in the application down here, myRectUnion. And what's going to happen is, as they drag around, it's going to call this addPoint method. Well, this addPoint, this is sort of a placeholder for, some API, it happens to take a point. You don't have an option here. You have to create a point structure to pass it into this thing. So every time, let's see, on click, every time they click down, this resolution is awful. Every time there's an on-touch event, it calls that addPoint, and it creates a new point object along the way. And every time they do that, we're going to create that new object, and we're going to collect garbage for it. So the tip there that I talked about in the slides before was, well, if you just need a temporary object sitting around to be a point object and you're going to use it a lot, then just go ahead and create the thing ahead of time. So I have this other thing in the commented out code that says, somewhere down here, that actually creates the point and then uses it and fills it in along the way. So we have temp point used instead. This could be a static object or an instance object, depending on your situation. And then we can simply fill in the values of the point instead of creating a new one every time we call it. So I think that's enough on that. So there's a great quote from some game optimization guy that said, "Premature optimization is the root of all evil." I would say it's the view root of all evil. So you can totally overdo this. I think it's a little bit weird maybe for some people to watch me talking about this stuff, because frankly this is the stuff that I think we all stopped thinking about a decade ago. But when I started working on the platform, in particular when I started working on animations and I was in inner loop code in the framework, I realized, you know, a lot of these techniques are actually useful, not necessarily to use all the time, but certainly to think about when you may run into them in your inner loop situations.
Well, and those techniques apply not necessarily to graphics code. I remember before we shipped Android 1.0, for instance, we had Google Sync that gets all your emails and calendar events. And it turns out that at Google, we have a lot of emails in our inboxes. And you know, the code that was doing the sync was creating too much garbage. And when it was syncing thousands of emails in the background on your phone, you could see the entire system like start slowing down because the garbage collector kept going on and on because of garbage created by the sync process. So it could be like you're querying a database, you're going through the results, you're downloading something from the web, you're parsing a file. Like anywhere where you have a long operation, anywhere where you have a loop, you should be careful about all that stuff. So to stay on the topic of memory, we're going to talk about memory leaks. So when we mention memory leaks, when it comes to the Java language, they are not actual leaks. Like you can always find the memory and free it. But it's very easy to allocate too much memory and kind of lose the references in your app, and you're still using that memory, and then suddenly your app runs out of memory, and then you start filing bugs saying that the framework sucks and that we're a bunch of idiots because, you know, your app is crashing. So I'm going to show you a couple of tools that we use all the time to track down those memory leaks. So first of all, we're going to use DDMS. And DDMS that Chet just demoed in Eclipse can also be used outside of Eclipse. So if you use another IDE or just a standard editor, you can also use DDMS and all those cool tools. And then we're going to use a tool called Haase. So Haase comes with a JDK. It means Heap Analysis Tool. It's a very bare-bone tool that works in the web browser, and it can be kind of a pain to use, but I'll show you real quick how to use it. Very important, if you suspect you have memory leaks, you can run this command. It works with your phone or with the emulator. So adb shell dump sys meminfo and then the name of your process, and we're going to show you a bunch of information about the process. So how many view routes you have active, how many activities, like the amount of memory you're using, and if you see the amount of memory go up and up and up and up, then you're screwed. So we have a small demo. So I modified the demo that we showed at the beginning of the previous talk. So we're loading a bunch of pictures. I am doing something wrong in the app. So if I rotate the phone to go in landscape mode, and we wait, because the emulator is a bit slow, we open one of those beautiful pictures, we switch again, and we just crashed. So if we go look at the logs in DDMS, and actually I'm going to leave Eclipse. So everything I'm doing will also work in Eclipse. So slightly different UI, exact same tool. Okay, so we pick our running device, we look at the logs to see what is going on, and we ran out of memory. So it's probable that we have a memory leak somewhere. So to analyze where the memory leak is, we just select our process, and then we can use this little button here, the second button from the left, that you can barely see. The tooltip, it looks like a green cylinder with a little red arrow, and it says dump hprof file. So you click on it. Here we go. We get a file that you save anywhere you want, let's say on the desktop. And then there's going to be another very important step. We have to convert that file into a format that Haase can understand. So in the SDK, there is a tool called hprofconv, and you simply run it by passing the file you want to convert. So I'm just creating another file called leak.hprof, and then we can run the tool called jhat that should be in your JDK. Desktop leak.hprof. There we go. So once the jhat tool is running, you can open a web browser and you can look at the localhost port number 7000. Localhost. Here we go. And this will show you a dump of the entire memory heap. So you can see every instance of every class that you have currently live in the application at this time. So now comes the fun part. You know there's a memory leak somewhere, you have to figure it out. And all you have is just every single object that lives in your app. So the best thing you can do is look at the instance count for all the classes. So you have two different links. You can barely see, so I'm going to zoom. There you go, should be big enough. You can show the instance count of all the classes excluding the Android classes. So you're going to see only the classes from your app. You can also show the instance count for all classes including the Android classes. So if you think you're leaking bitmaps, for instance, you should look at the instance count including the platform. We're going to look at only our classes. So these are all the classes from my application. So we have 11 thumbnails, for instance. And something that's really weird is here, I have two instances of a class called picture, and picture is my main activity. So that means that somewhere along the way, as I was rotating the screen, I lost a reference to one of those activities, and it remained in memory. So you just click on those instances. We're going to click on the old instance, because this is most probably the one that we leaked. Here you can see a bunch of information like the value of all the fields, blah, blah, blah. And what you want to click on at the bottom, you want to find the reference chains from the root set. So those are the chains of reference that keep your objects alive in memory. And there's a link here called exclude weak references. If you know how weak references, you'll probably understand why. If you don't, you should definitely learn about weak references. So we're going to click on the first link. And here you can see all the references to my object. Most of them don't actually matter. And we can find one here that's pretty weird. So it's a static reference from a field called spictures in my class. So spictures is a hash map that I've created. It's a cache that contains all the bitmaps that the application is displaying. And if we look at the chain of reference, we have the hash map. An hash map entry, some stuff, then we see the bitmap, so it's a bitmap drawable, that's my picture. And that bitmap has a field called mCallback. And the mCallback is referring to something called PictureView, and PictureView has a field called mContext, and that context is contains my activity. So what's going on here is that I've created a static hash map, and the first time I load a bitmap, I put it in the hash map. So the first time we launch the application, I'm like, oh, a new bitmap I don't know about. Let me put it in the cache just in case I need it in the future. Then we rotate the screen, but that bitmap kept a reference through that callback field onto my old activity. So we kept all the memory that was used by the first activity. And so to fix that, I would have to change my hash map, my cache, so that it doesn't keep bitmap drawables, but it keeps just bitmaps, or so that somehow resets the callback to null when we destroy the activity the first time. This is a very difficult topic. There's a lot to say about memory leak and on how to track them. There are some generic advice that you can find here. So be very careful with static fields. Be very careful with the context object, because an activity is a context, and the context is passed all over the place. So if you leak an object that has reference to the context, you're leaking the activity, and you're leaking all the views, you're leaking all the bitmaps, all the text. It's a lot of memory. So be very careful with the context. Avoid non-static inner classes, or avoid inner classes if you're not sure, and use weak references when possible. I wrote a blog entry on developer.android.com on this subject. I go into more detail, so you should look into it. You can also use, instead of HAT, there's a tool called MAT. It's the memory analysis tool. It's a plugin for Eclipse. It's also a standalone tool based on the Eclipse platform, and it works with our SDK. So if you dump the heap from our Eclipse plugin and you have Mat installed, we would automatically open Mat. And Mat, everything that I showed you, like trying to find a leak instead of doing manually, Mat can try to do it automatically. You get a lot of false positives, but at least it gives you a good graphical view of the heap instead of just, a simple HTML file.
I ran my slide. I'm done.
Responsiveness, it's very important for your applications to be responsive. So very similar to a lot of UI toolkits, the Android UI toolkit is single-threaded, and you cannot use multiple threads to access your UI object. So if you have several threads that try to modify a view, it might work. It probably won't. And actually, so many people were doing that I introduced a special exception in ListView, where if you try to modify ListView from another thread, you get like 10 lines of exceptions saying, you are doing it from another thread, don't do that, please. And I still get bug reports from people saying, hey, I see this exception in my code. It's not my fault. I'm like, well, it says it's your fault. So they don't believe me. It's always their fault in the end. Anyway. So it's very important, because we have a single thread, it's very important that you don't block it. If you do anything that takes a long time on the UI thread, let's say you have a click handler for a button, and in that click handler you decide to load a file or do a database query, well, you're going to block the UI. What does that mean? That means that you're going to prevent the user from dispatching touch events or key events to the system, so the UI will not be responsive. You will prevent the UI from redrawing, so you will see your button highlighted in orange, for instance. It will stay in the press state because we can't redraw it in the non-press state. And you might also get what we call an NR, so that's application not responding. You've probably seen that if you use an Android phone. If an application spends more than 5 seconds processing a single event on the UI thread, we pop up a dialog asking the user if they want to wait for the app or if they want to kill the app. So if you see this dialog pop up, it's definitely your fault and your code is bad and you suck and you should fix your app. We also see that a lot in our code, I promise. So we have different ways of dealing with it. One of the easy ones is called the Async Task. If you are familiar with Swing and the Swing worker, it's very similar. The idea of an Async Task is to make it very easy to spawn a worker thread to do a lot of work on this background thread and then to post a result on the UI thread. So if you use an Async Task, all you have to do is override a couple methods. You don't have to worry about synchronization. You don't have to worry about messages, any of that. It's all done for you. Again, if you go to d.android.post about async task, and you can find, and the documentation now actually gives you an example. You can also use a handler. A handler is basically a simple messaging system for the UI thread. So all you have to do is when you're on the UI thread, you create a handler by saying new handler. And then on that handler, you can post messages. You can post runables, or you can post actual messages identified by numbers. When you post a runnable, all it does is it enqueues this runnable at the end of the list of events that have to be processed. And it's a way to split long tasks into smaller tasks. Very useful, and if you look at the source code of Android applications, you're going to see the handler used all over the place. And one last thing, Async Task basically uses a handler behind the scenes, so you can look at the source code of Async Task to see how it works.
I was talking about writing custom manual animations before I mentioned handlers at that time, because if you're going to write an animation that manipulates objects in the view hierarchy, you need to do it on the correct thread. So you can basically create a handler that handles the timing events, and then when you get that timing event, you can do something with it and know that you're on the correct UI thread. So I'm going to talk about a tool I like called TraceView. I like it so much I'm going to run it twice tonight. So the tip here is to only actually force a redraw of the stuff that you want to. So I have this demo, which overemphasizes the point just a bit. Let's see. I'm going to need to run DDMS. Yeah, over invalidation. Okay, so now see, this is the fixed version. So were I running the buggy version before I fixed it? So you have a view here, a view group with all of these buttons inside of it, and then on top of the buttons that you have in there, you want some custom drawable there. I happen to draw a ball because I like doing that. You may draw something more useful in your application. But the key is, if I want to redraw this for every frame of this little animation that I have here, then I need to invalidate my view group. I need to tell it, okay, I need to be redrawn because the ball has moved since its last position, so go ahead and get a draw event so that I can actually draw the ball in the correct place. And the easiest way to do that is to call invalidate. You just say, okay, for this view group, invalidate, empty parentheses, just basically invalidate your entire self, and then I'll do the right thing. And it does do the right thing, but along the way, it's going to do way, way, way more than you need to, because it's going to draw all of its children, right? All of these little buttons, and each one of them, it may not look very complex, but there's a lot going on behind the scenes. And my frame rate went down from, right now you're getting probably 100 or 200 milliseconds in between each frame on the emulator. It went up to like a second to 2 seconds, simply because it was drawing all of these empty buttons and then drawing the ball. So the trick here is to not call invalidate, but instead to call invalidate on the region that you care about. So there are a couple of flavors of invalidate, and one of them it takes a rectangle, and you basically pass it in the region that you want to invalidate instead.
And actually, there's a tool that you can use in the emulator and even on devices to make sure that you're invalidating the correct region of the screen. So if you launch the application called DevTools, and then you go into development settings, then you can click show screen updates. So what it's going to do is going to flash the region of the screen that gets invalidated. And here we have a good example on the home screen. For instance, when I move this button around, oh no, that's the new home screen that does something completely different. It's actually faster than before, but it looks like it's not. Anyway, so the sucky version of Chet's demo, we are redrawing the entire screen, we're redrawing all the buttons, and if we go in Eclipse and we fix the code, the invalidate, here we go. It's taking some time. Here we go. That's much better. And you can see here that now we're doing the right thing in the code, because we're invalidating only the old position of the ball and the new position of the ball.
Actually, you can, for the total graphics geeks, you can see that it's doing a union of the regions that I asked for, because as it gets to the right of the screen, it's actually drawing a larger rectangle, because I said, I want to redraw this area, and it says, okay, I know how to combine those regions into one.
Okay, some optimization tricks for your UI. Don't use too many views. The fewer views, the better. If you have too many views, it's going to use a lot of memory, and you want to preserve the amount of memory you have. It's going to be also slow to draw, it's going to be slow to do the layouts, and it's going to be slower start times. And on some devices, you can even get Stack Overflow exceptions. We keep the stack size pretty low on purpose to make sure that applications don't abuse the UI Toolkit and put too many views on screen. So we have a few tools to help you create nicely behaved applications. So for instance, we have a tool called Harkey Viewer, and pronouncing that name is very hard for me, and I picked that name. I hate myself. It's part of the SDK. We have a new version coming up that is going to be integrated in Eclipse. So you just run it from the SDK, and that's the new version. Do you have the old version somewhere? We're going to use the new version. Yeah, no, that's okay. We're going to use the new version. A glimpse of the future. So you select the window you want to inspect. You can select by default the focused window, but here you have a list of all the windows in the system. So here we have launcher, we have the wallpaper, stuff like that. We're going to click Load View Hierarchy. It's going to load, take a dump of the entire window, not just take a dump of the window. And now we can see the tree, a representation of the entire launcher right now. So if you click on an item, you can get a screenshot capture of that view. So if you have rendering artifacts, you can try to see exactly where it happens. And actually, if you click that little button here, you can get a bigger version of the screenshot. with this. For every view, you have a bunch of properties. So if I zoom, we can inspect the values of different properties, so we can see if the view is clickable, it's enabled, the layout width, the layout height, if it's visible, stuff like that. All the properties that we export here are just annotated in the code using an annotation called viewDebug.exportProperty. So if you create your own views or your own view groups, you can just put this annotation on any field or any getter, and it will automatically show up in the tool. The tool also shows you a wireframe of your application, so you can see how the views are laid out, where exactly they are on screen. It will also give you performance indications about the application. So, for instance, if I can make... okay, it doesn't work with that version of the system. But with Gingerbread, or the old version of the tools, it shows you how many views you have in that container, and it will show you how long it takes to measure that container, how long it takes to do the layout, and how long it takes to draw it. So if you're making optimizations, if you're removing views, if you're improving your code, you will see those numbers get better. You can also do stuff like you can force invalidates, you can force requests, and you can also export. You can export the whole window as a Photoshop file. Every widget becomes a PSD, a layer in the Photoshop file, and the name of the widget in the code becomes the name of the layer. So it's a nice way to create mockups. And you also have access to what we call the pixel view. So inspect screenshot. It's a real-time representation of the device. So it works with phones as well. So you can inspect the colors of your application, and if you click an item, you can see exactly where it is on screen. So you can see the boundaries of the item, you can see the padding, you can see the margins. Makes it very easy to debug issues.
So I should point out, we're sort of running the bleeding edge of the tools, but this stuff is actually all being developed in the open, the SDK stuff. I think I grabbed the latest bits from that team, but I believe those are actually buildable because they do check-ins in the open. So this is not something you couldn't get your hands on. It's more that they do regular releases, and I don't believe that release is posted, but I think the bits leading up to that release are being developed in the open, so you can check that out. So if you go download the SDK, you basically get the plugin and all the tools that we're talking about.
And now, really quickly, because we're running out of time, we're going to talk about various ways you can optimize your layouts. A bunch of different methods. First of all, you can use something called the ViewStub. The ViewStub is something really cool. So in many applications, very often there's a bunch of widgets that you're not going to be using very often. For instance, I wrote this application that just lets me manage my books, and I can import books from a file on the SD card. Well, when I import the books, I have this progress bar that appears on screen, but obviously I don't import books every day. So what I did to avoid having the progress bar and the cancel button and all that stuff like loaded all the time, taking memory, slowing the startup, I use a ViewStub. So this is a snapshot with the old Harkey Viewer tool of this application. And here I have two view stubs. And the property of a view stub is that at any time, at runtime, you can expand it into a bunch of other views. So here, for instance, I had this import view stub, and I clicked the import button in the app, and suddenly the ViewStub view turned into this subtree of views where I have my cancel button, my progress bar, and my label. Once it happens, those views will stay in memory, so you still have to make them invisible or hide them somehow when you don't need them. But at least until the user needs access to those views, they won't take any memory or they won't cost you any performance. The merge tag is another useful tag that's not very well known. So this is an application. If you write an application, the Android system will create a bunch of views for you. So everything that's above this blue rectangle is created by the system. So it's basically the title and the rest of the window decorations. So I wrote a very simple app where I have an image and a label, and because it's XML, I need to have a root tag. So I just created a frame layout as the root of my XML. Now the problem is, if you look at the parent of my frame layout, it's also a frame layout. So I have a frame layout that contains a frame layout. They have the exact same size. So one of them is actually useless. It takes longer to do the layout, it takes longer to do the drawing, so I should be able to get rid of one of those. The problem is that in XML, I have to have a root tag, so I need something instead of the frame layout. What I want is this. I want only one frame layout. So to achieve that, we use the merge tag. And the merge tag basically tells Android, okay, I have a root tag here, but it doesn't do anything. Just forget about it. The parent of my content is actually the parent of whatever is inflating that XML. Again, go to the blog, the official blog. There's an example of that. Compound drawables. This is something we see a lot in applications. You need an image and a label next to the image. So you create a horizontal linear layout, you create an image view, you create a text view, and you have 3 views, 1 level of view group. This is a lot of work to just draw an image and a label. So instead you can do this. We have the notion of compound drawable. So you can specify the left drawable, the right drawable, the bottom drawable, and the top drawable in a text view. You can do that from code as well. And if you're not sure about what you should be doing in your layouts to improve them, we have a tool in the SDK called Layout Opt for Optimize. It's very simple. It's a command line tool for now. We hope it's going to be integrated with the Eclipse plugin someday, so that it's more graphical and it happens, and it's used automatically as you create your layouts. To run it, you just run the command layout opt, and you give it a path to one of your layout files. So, for instance, I have this one here. And it does a static analysis on the file and tries to figure out what you could be improving. So here it's telling me that this tag and its children can be replaced by one text view and a compound drawable. So it found a horizontal linear layout containing an image view and a text view, and it knows that you can replace all of that by just one text view. Layout opt, because it's static analysis, cannot be 100% correct. So you have to be careful on how you apply what it tells you to do, but it will give you good advice most of the time. I will run another example. You can also run the tool on an entire directory of layouts. So it has tons of advice. So for instance, here it figured out that there's a bunch of useless linear layouts in my application. Here it figured out that I have a frame layout as the root tag of my layout, and it can probably be replaced with a merge tag. Here it's telling me that I have too many views, and here it's telling me that my linear layout is using the wrong layout width, and it's not the most efficient way of setting up that linear layout. Once again, tons of different optimizations you can apply. Run the tool against your XML files, and you might be surprised by what you find. ListView is a very, very complex topic. We won't go into too much detail here. So you probably hate ListView. It's probably totally my fault too that you hate ListView. Believe me, I spend a lot of time in my life dealing with it, and I hope I will never have to anymore. Yes, so at Google I/O 2010, 6 months ago, Adam Power and I did a talk called The World of ListView. It's an hour long about ListView. It's very boring, it's very dry, it's very important, you have to watch it. This is basically, no, actually the talk is not that bad. We crack jokes and stuff like that. This is a summary of the talk. Anyway, so you have in your adapter that feeds the items in the list, you have to implement a method called getView. And the naive way of implementing it is like this, for instance. So I'm inflating a view from XML. I have a text view, I set the text on that text view. I have an image view, I set the image, and I return that. Well, it's all fine, except it sucks. A better way of doing it is to look at this parameter called ConvertView. ListView is a very smart and very complicated piece of code that tries to recycle as much as it can. And it will give you sometimes a ConvertView that's not null. When that ConvertView is not null, instead of inflating or creating a new view from scratch, you can reuse that ConvertView directly. ListView guarantees that it's going to be exactly the type of view you need. When the ConvertView is null, then you can create it. There's a third way that's even better. It's what we call the view holder pattern. So there's some stuff that you do over and over again in GetView. For instance, here, even when we use the ConvertView, we always do those two find view by ID. We find a text view and an image view. Well, we shouldn't have to do that every time. So instead, we create a view holder. So it's a very simple structure. And in the holder, we're going to keep a reference to the text view and the image view. And we're going to do the find view by ID only once when we create the view the first time. So now the code looks like this. You inflate the view from XML, you create a view holder, you do the find view, you store the result, and then we keep that view holder as a tag. On View, we have this method called setTag that takes an object. It's meant so that you can store any kind of data you want inside a view. And that's what we're doing here. We're storing extra data that we can reuse when the ConvertView is not null. We get that, we call getTag, and we know it's a holder, and then we can use the text view and the image view directly. And why is it important that you do that? Is because if you write the first version of the code, you're going to run at 20 frames per second. If you write the second version, you're going to run at 50 frames per second. And with the third version, with the view holder, you're going to run at 55 frames per second, which happens to be the refresh rate of the display, which means that you can't go faster than that. And those numbers were taken using a ListView of 10,000 items running on Froyo on the Nexus One. Finally, graphics optimization, don't scale your bitmaps and runtime, blah, blah, blah. Compatible bitmaps, we talked about it. Avoid blending. If you don't need transparency, don't use it. Use drawing caches. Very important, if you have custom views and you know that your view is going to be opaque, override the method called isOpaque and return true. That's a very important optimization for the system. When a view is opaque and we need to redraw that view, we won't draw what's behind. And the same information as before, visit the official developer website. There's the official blog. We have a bunch of really cool articles about new APIs, best practices, tips and tricks. When we announce Gingerbread, you're going to find like a lot of articles about the new APIs, so watch out for it. Our websites and Twitter accounts. And it's time for more questions. And we don't have a question slide. So the question is about the new 32-bit format by default for bitmaps. Is that for just JPEGs or everything? It's for everything. It just happens that before JPEGs were the only ones decoded in 565. We never said. I mean, it's just an implementation detail. It's not mentioned in the API. There's no guarantee what the format's going to be. So you should always check the format. And actually, we've seen a few applications, and we worked with the authors to fix them. But we've seen applications that crash because I think there was this 3D game where they were assuming that the format of the image would be 565, but it wasn't anymore. And then the app, for some reason, was crashing. But never assume anything about something that's not in the documentation. Do we use mostly the emulator or devices when you write applications? Actually, it depends on who you're talking to on the Android team. Some people use only the emulator, pretty much. So, like myself, I use only devices. Everybody has different ways of doing it. But I can tell you that most of the framework was developed on the emulator because we did not have devices at the time. So it was a lot of fun to implement touch stuff with the mouse.
I think that's all the time we have, so I think we're done. Thanks.